Hello and welcome to our tutorial about covalent bonding. We're going to be talking about the definition of a covalent bond, sharing of electrons between atoms, and how to make or draw a diagram of a covalent bond. So firstly, what is a covalent bond? Well, it's an attraction that happens when atoms share electrons with other atoms. This is sharing electrons that causes an electrostatic attraction between the atoms, which results in a covalent compound. Covalent compounds can have very strong bonds. They hold compounds together, so for example, sugars, proteins, diamond all have only covalent bonding. They can have high melting points and high boiling points, but there are examples of plenty of covalent compounds that don't as well, so there is a much greater range of bond strength with covalent bonding than there is with ionic bonding. Okay, they don't conduct electricity. There are very few exceptions. You probably know about graphite as being the key exception that we need to know about. So sharing electrons. This is when atoms of non-metals share electrons without actually exchanging or transferring electrons. This enables the atoms to effectively have a full outer shell each. The atoms remain neutral without a charge, so they don't become ions. Okay, so let's see what a simple covalent bond looks like. How would we do it? So let's use hydrogen, H2, as our example. This is a molecule that has two atoms of hydrogen. So there we can see two atoms not yet bonded of hydrogen. They each have only one electron shell, and each has only one electron in that shell. Now the first electron shell can accommodate two electrons only, so hydrogen atoms each need to share a further electron to fill their outer shells. Hydrogen atoms can do this by sharing electrons with another hydrogen atom. So that forms a covalent bond, and to show this we have an overlap of the atoms in the diagram. I'll show that in a second. The electrons being shared are shown in that area being overlapped. So here we are. This is the overlap area, and here's the two electrons being shared. In this case, there's one covalent bond in this molecule. Each covalent bond needs two electrons. So any covalent bond requires two electrons to be shared. Okay, another example we're going to look at is the chlorine molecule, Cl2. There we go. So each chlorine atom has two electron shells, and they have 7 electrons in their outer shell. So if you look at each of those atoms, you'll see 7 electrons in their outer shells. And I've just used dots and crosses to distinguish between the two atoms. Actually, those electrons are, of course, exactly the same. And the other thing you should notice is we're only showing the outer shell of the chlorine atoms. We do this with all the atoms when we're showing covalent bonding. It would get too cluttered and unnecessary to show inner shells. So chlorine's outer electron shells can accommodate 8 electrons. So chlorine atoms need to share a further electron with another atom to fill their outer shell. And they can do this by sharing an electron with each other to form a covalent bond, and we're going to have an overlapping area showing the covalent bond. Again, the electrons being shared are in the area being overlapped, as you can see here. And again, there is one covalent bond in this molecule, and it has 2 electrons in. Okay, how about the case of a double bond or a double covalent bond? So for this we're going to use the example of an oxygen molecule O2. So each oxygen atom has 2 electron shells, and they have 6 electrons in their outer shells. Again, we've only shown the outer shell. So for each of those you can see 6 electrons marked. Oxygen's outer electron shell can accommodate 8 electrons. So oxygen atoms would need to share a further 2 electrons with other atoms to fill their outer shells, and they can do this by sharing 2 electrons from another oxygen atom to form a covalent bond. And we're going to have an overlapping area showing the double covalent bond, and in there we'll see the electrons being shared. You can see there's 4 electrons in that area, so that's 2 covalent bonds. Okay, how about molecules that have more than 1 covalent bond? So we're going to have a look at an example of this. This is the water molecule. So here the atoms individually, we have an oxygen atom and 2 hydrogen atoms. The oxygen atom again has 6 electrons in the outer shell, and the hydrogens have 1 electron in the outer shell. The oxygen atom wants to share 2 electrons. Each hydrogen wants to share 1, and the way we can do that is for the oxygen atom to share 1 electron with each of the hydrogens. And that will form 2 covalent bonds. We're going to have 2 overlapping areas showing the covalent bonds in this molecule. And again, the electrons are in the overlapping areas. So here between this oxygen and this hydrogen atom, we have this overlap with 2 electrons. And between the oxygen and this hydrogen atom, we have this overlap, another covalent bond with just 2 electrons. So we have 2 single covalent bonds in this molecule. So in summary, covalent bonds are formed by sharing electrons. Each bond requires 2 electrons to be shared between the atoms. It is possible to have double bonds by sharing another electron pair. And molecules can include a number of atoms all covalently bonded. Covalent bond is caused by a strong attraction between the atoms sharing the electron pairs. These are strong bonds, and so covalent bonds can have a high melting point and a high boiling point, but not all covalent compounds do. They don't conduct electric current when molten or in solution because they don't have any ions to carry the current charge. Okay, so that's the end of this tutorial. So tomorrow we're going to look at numbers and calculations. So we're going to look at relative atomic mass and relative formula mass, or if you're studying Scottish Nationals, that's gram formula mass, you'll know that as. We're going to talk about moles, how to work out the mass of products or reactants, and percentage yield.